Hey brilliant minds and innovators, welcome to Irfan.ai YouTube channel. Here I share some practical examples about LLM powered applications to explore different use cases. If you are passionate about AI and you wanted to figure out how you can supercharge your project with AI, you are in the right place. Before I want to start going through the code architecture and implementation, let me tell you something.
Wait. Let me tell you something. All right. Let me tell you something. Wait.
Sooner or later, AI will be an inevitable part of each business and individual. It already has been started so far.
And I want to thank ChatGPT for helping me doing all my assignments, my thesis and everything.
So you should be more curious and you should do serious investment on your skills related to AI and LLMs to be more productive and successful. Now let's back to the concept. In this episode, we start with defining the problem and exploring different solutions. Then we will go through the code implementation and architecture that we wanted to use. Think you are a researcher. So the steps that you should go through is first of all collecting all the papers, reading the papers, then maybe writing side notes, and also maybe sometimes you wanted to write summary about those papers as well. So for example, after basically reading all those documents, you have a question about the specific thing on those papers. So how do you usually do that? First of all, you should go through all the papers, find a specific paper that basically talks about that specific topic, right? Then you should go through the page, skimming the page, and find the concept that you are looking for. And maybe in some use cases, you can go through the Google Scholar and search through that panel or that portal, or maybe any kind of similar software to find the relative context of that question in different papers. So this is a valid approach, but what if I tell you that you can build some simple, easy use case, straightforward kind of approach for solving this problem? In this episode, we wanted to build an assistant for researchers to kind of simplify their procedure of finding related topic and also kind of help them to talk with their paper and find out their questions. So let's dive into the code. First, we look at the architecture, then we will go through the code. Let's start by checking how exactly ReAct frameworks are working. If you look at this flowchart, so the main steps of different kind of ReAct frameworks are almost the same. So first of all, the problem is we wanted to use some documents and kind of inject or ingest those documents for our LLM and help our LLM to basically answer the specific question based on those concepts or based on those content as a main context. So let's go through that. The first step is chunking data. By chunking data, I mean whenever you have a documents, so your documents should be parsed in a different size, in a specific size. And those size is related to the vector size of our vector database and also our LLM. Because so in different LLMs, we have a different size. So we cannot kind of go more than those maximum size of each document. And there is a trade-off. We cannot go, for example, for let's say 8K context for each document and expecting kind of more accurate data retrieval. So basically, if we have kind of smaller chunk, we can have more precise retrieve document from our index or vector database. Next step is indexing and vectorizing. So the main thing about neural networks are neural network they cannot understand text or strings. they understand numerical data. So we should convert each chunk to a vector of numerical data. Then it can be kind of consumed by our LLM. So in this step, we kind of vectorizing all the chunks and store all those basically vectorized chunks to some vector database, which we can say it's an indexing phase of our procedure. The next step is query engine. So basically, query engine is the kind of one of the interesting solutions that proposed by LlamaIndex. So the way that it works is, first of all, you ask a question, then after you ask a question, it will be vectorized on the procedure. Then it will kind of perform some similarity search on the vector database. And by vector database, I mean those kind of vectors that are kind of converted from a string to numerical vectors. And after that, we get top K. Usually we are using 3 basically as a K parameter for our similarity finding. And after that, we have kind of knowledge and question. So we use that knowledge, that kind of retrieve knowledge from vector DB and our question as kind of context for our LLM. And then we will put all those things to our LLM to generate a related answer based on our retrieved document. Now let's go to the code. First step is installing necessary documents. In this episode, we are using LlamaIndex as our orchestration tool. So we install LlamaIndex core, LlamaIndex, and OpenAI related libraries of LlamaIndex. After that, we use wget to download some paper. So you can use different kind of papers. I tried to use this sample, which is also used on a LlamaIndex tutorial as well. So this kind of paper is about LLM compiler, and I wanted to kind of do some research about LLM compilers, and I have some couple of questions, and I wanted to basically get my answers by this approach. This is the reason that we wanted to do that. Okay, let's go through that. With wget, I can download all these papers. So as I mentioned, you can have multiple papers. You can, have whatever paper that you want. I will save this paper on this directory. And next step is defining our LLM. So in this tutorial, I'm trying to use GPT 3.5 Turbo, which is one of the OpenAI models. It's not free, so you should basically create an account and having OpenAI key in your environment file. So setting in new LlamaIndex library is kind of connector between different modules. So whenever you wanted to kind of use the default setting of your approach, it's better to define your default setting. So this is the way that you can define your default, for example, LLM here. The next step is kind of reading all the documents. So with this simple directory reader, I can read all the documents or PDFs available in this folder. As you can remember, this folder is the place that we are storing the different papers that we want to kind of work with. The next step is chunking. So basically the chunking approach here in LlamaIndex usually kind of defined with nodes. So this is the nodes that we wanted to work with, and again, nodes are chunks that we want to split from the main document. Now we wanted to store our nodes or chunks to some vector database. Here we store our chunks or nodes in a vector database, and then as you can see, whenever you call as retrieval, it means that you just wanted to use this index as a retrieval, and it means that you just need to retrieve the similar document. That's it. You don't need any kind of further processing on that. But when you use query engine, it usually means that you wanna first get the kind of related documents, and then use those related documents as a knowledge for your LLM to get more accurate response. So we are going with query engine nodes, and let's kind of try some example. Here I ask my document, my paper, to explain me more about LLM compiler. As you can see, the response is good, and it explains to me what is LLM compiler. And as you can see, I can see the reference on the paper as well. And if you go through that, you can see also the score as well. So the similarity score is about 84%, which is good. The next thing is I wrote the code to basically show us what is the basically similarity of each document, because as you can see here, we ask our query engine to get us top 3 similar documents. So as you can see, the similarity score of each document is near 85%, which again is good. Now we wanted to use this query engine in our agent. So first we built some query engine tools. So this query engine tool kind of let our LLM to know that we have some functionality in our orchestration framework that you as a LLM, you can ask that a specific, let's say, function or tool to give you more specific data. So here also we create a description for this query engine tool. It also can help LLM to kind of define when exactly or in which situation it can use this tool. So whenever we wanted to know more information about LLM compiler or parallel function calling, we can use this tool. And let's also use ReAct agent. So the main basically philosophy, let's say, behind a ReAct agent is, so you create a bunch of tools and you basically give these tools to your agent or LLM. And you also kind of with, let's say, few shots, you can teach your LLM when and in which situation it can use those kind of specific tools with description and function name. So it's like you give your AI some different functionality that it can use those functionality to connect to kind of, let's say, outside of its knowledge. Let's go through the question. Now we create our agent and now we wanted to ask a question. And as you can see, so if you set verbose to true, we have step-by-step kind of a function calling as well. As you can see, I ask a question from our agent, right? The next step is the agent is thinking about the question, and it recognized that it can use LLM compiler, which is our tool, to kind of get more information. And after it got more information, it understood that it's enough. It kind of doesn't need to go any further step, and that's it. And now we have a nice answer. And as you can see, the answer is kind of good, and it's related to our document. Also, we have a source node, which is kind of reference to our node as well. Another good feature of agents is memory. So by memory, I mean whenever you wanna to start chatting with your LLM, right? So you kind of need to have your kind of previous chat history with your LLM, because it can help your LLM to give you more specific answer based on the previous chats as well. So when you build your ReAct agent, ReAct agents, they have also the memory built-in memory somehow. It's a really nice kind of architecture. It's not that much complicated. And if you wanted to check the basically question history of your question, you can also check this react.memory as well. And sometimes you just need to build a query engine without a React tool. For example, if you wanted to build a pipeline and you wanted to get a specific answer, and you want to have some kind of stateless question answering. By stateless, I mean you don't want to basically store the historical chat or consider those historical chat as well. So in those scenarios, you just need to use query engines, and it would be enough for your use case. If you found this tutorial helpful, please smash the like button and subscribe button, and also hit the bell icon as well to get updated episodes as well. If you have any question about this episode or have a good idea about next episodes, please drop a comment. And you can find the code of this project in the description. Have a good one.